Right, so I have this binary number ordered truth table. I want to do the Karnaugh map, to do the simplification. I start off by putting it in the gray code ordered truth table. And I'm going to block it off in units of 4 to start off with. So that first row goes here. And it's 1, 2, this, and then you sort of skip to the end and come back. So this would be 1, 1, 1, 0. Then the next one, I'll make, I don't know, green. They go here, and again, it's 1, 2, skip, and then come back. 1, 2, skip, and then come back. And now it's our turn to skip in the rows. So this next guy, then I'll make blue, goes down here, because the third one is where you skip to the end and then you come back. And then that is 1, 0, 0, 1, and then this last one is 0, 0, 1, and come back. Okay, did I give myself much to simplify? Not a lot of simplification here, but let's go with it, and then I'll probably do a don't care one. So we are looking for either ones in 1 or 2 or 4 or 8. It has to be a rectangular group, and we have to watch out for the possibility of wrapping. Okay, so I have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8 ones I have to account for. Let's start putting them in groups. This first one up here, he is a candidate to map with a bunch of people. He can team up with the guy right next to him. You always ask, can I do more? I cannot extend the whole row, so that's no good. But can I go down to the next row? No, I can't, because it's got to be all ones and there's a 0. Can I wrap? No, I can't. Okay, because again, there's 0. So that's a possible. I'm going to write down the possibles and then write expressions for them. So that is the first row. First and second column. Okay. That would be these two. This guy could also have teamed up with this guy over here. He can wrap. And he can go down to the guy below him, and he can wrap this way. So he can team up with a bunch of people, but it never leads to a foursome. These two can make a foursome with those two because of that 0. This guy and this guy we already talked about can't make a foursome with this other guy because of this 0. But this guy can be accounted for in many groups. So let's just put him in all of his groups. So that was, I teamed him up with this guy. I can team him up with this guy, first row, first and last column. That's teaming him up with this guy. Let's team him up with the guy below him. That's the first and second row, the first column. The first column. And I can team him up with the first and last row, first column. So he's in lots of groups, but none of those groups all those groups are pairs, but he's in a lot of groups. First and last row, first column. And that would take care of this guy, this guy, this guy, this guy, and that guy. So that takes care of 5 of my 1s of my 8. And let's write the expression for them. And I can't do any better. I can't make any bigger groups than that. And they're always taking account of, I'm not making an extra group because I have to count for all those guys. And those guys are not, none of those guys are in other groups. This guy can't really team with anybody other than that guy. This guy can't team with anybody other than that guy, this guy. So none of them are in other groups. So I need to account for all these groups. So the first and last, this is the first row, the first and second column, that's here. You always ask which input changes, and the input that changes when you have a pair, these are all pairs. When you have a pair, you only expect to lose one input. The input then changes is the one that you're going to throw away. So A does not change, B does not change, C does not change, but D changes. So D is what I throw away, and I keep the others. They are all zeros. The A, B, and C are all zeros, so they all get primed. A prime, B prime, C prime. Then I'm going to, this is a sum of product sort of a thing, so I'm adding the next term, the first row, the first and last column. And so the thing that is changing this time from the first and last column, the first column, the last column, this time it is C that changes. And again, A is 0, B is 0, and D is 0. So this next guy is A prime, B prime, D prime. And then there's the first and second row. So that's here, that's this pair. And this time the input then changes as B. In the first and second row, A is always 0, but B changed from 0 to 1. That's the thing we're throwing away. C is 0, D is 0. So this one is A prime, C prime, D prime. That was these two. And then the last one, it is the first and last row. So this time it is the A that changes. In the first and last row, A is 0, and then A is 1. That's the thing that changes. That's what I'm throwing away. I'm keeping B, I'm keeping C, I'm keeping D. They're all zeros. So this guy was B prime, C prime, D prime. Now, if you look at these, you can, now we know visually that none of these were in larger groups, but we can also confirm here sort of algebraically, these all differ by more than one term. Either they have a different component completely. These two have, one of them has a C, one of them has a D. None of them have anything that can further simplify. So I've taken care of, I'm going to put an X next to everybody I've taken care of. And that was all these guys. So now I have this one here in this green row. He is surrounded by zeros. There's no simplification whatsoever there. So he's all by himself, no simplification. He's going to need all 4 terms. So that is the second row. Third column, all by himself, no simplification. And what is he? He's A0, B is a 1, C and D are 1s. It's A prime, B, C, D. That was this guy. He's now taken care of. And this guy is, he's surrounded by zeros. 0, 0, 0, 0. So there's nothing to do for him. And this guy down here is surrounded all by zeros. So again, this example did not have a lot of simplification, but let's take care of everybody. Third row. Last column. That was here. Nobody, he's above him is a 0, below him is a 0, to the side is a 0. If I wrap around, there's a 0. He's surrounded by zeros, no simplification. So I'm not going to lose any letters, but who are the inputs? A is 1, B is 1, C is 1, D is 0. So that's prime. So A, B, C, D prime. That was this guy. And then I have this last guy down here, last row, third column. And that was A is 1, B is 0, C is 1, D is 1. So B gets prime, A, B prime, B, B. Now everybody's accounted for. So that is my simplified expression. So I have to identify the groups. Everybody has to be in a group. You can be in more than one group. And then the number of things, if it's a loner that was in a group by himself, then there's no letters lost, there's no simplification, but we still have to account for him. If you have a pair, you're going to lose 1 letter. If you have a foursome, you're going to lose 2 letters. If you have an octet, you're going to lose 3 of the letters and only keep 1. I cannot have 6. 6 is not allowed, but 6 is 2 overlapping 4s. All right, so I'm gonna stop that recording.